Hello and greetings to everyone. We are going to correct the following exercises for application. Question 1 says, find the range of each of the following functions with domain x belonging to the set of real numbers. For us to find the range of the following functions, we are going to make use of the method of completing the squares. For A, we have f of x is equal to x squared plus 4x minus 2. This will simply be equal to x squared plus 4x plus, we are going to add a half the equation of x, all that squared, which is 2 all the squared minus 2. Then we subtract a half the equation of x, all that squared. This will simply be equal to, we know this is a perfect square, which the factorization is simply x plus 2 all that squared minus 2 minus 2 squared gives us 4. And this will be equal to x plus 2 all the squared. Negative 2 minus 4 gives us negative 6. We know that for x we take from the set of real numbers, x plus 2 all the squared is always greater than or equal to 0. Next step, we are going to add negative 6 to both sides. This will give us x plus 2 all the squared minus 6 is greater than or equal to 0 plus negative 6 gives us negative 6. We know this is our function f of x. For every x we take from R, function f of x will be greater than or equal to negative 6. Now we can write down the range. The range of our function f of x will simply be equal to the set y equal to f of x such that f of x is greater than or equal to negative 6, for x belonging to the set of real numbers. So this is the range of our function f of x equal to x squared plus 4x minus 2. We go to b. For b, we have to find the range of the function f of x is equal to x squared plus 3x plus 5. F of x is equal to x squared plus 3x plus 5. Now this will simply be equal to x squared plus 3x plus, we add half the equation of x, all that squared, plus 5, we subtract half the equation of x, all that squared. This will be equal to, this is a perfect square, x plus 3 over 2, all the squared, plus 5 over 1 minus 9 over 4. 3 squared is 9, 2 squared is 4. This will simply be equal to x plus 3 on 2 squared plus, we know the LCM of 4 and 1 is 4. 4 divided by 1 remains 4. 4 times 5 is 20. We bring down the minus. 4 divided by 4 gives 1. 1 times 9 remains 9. So this will simply be equal to x plus 3 over 2 all this squared plus, we know 20 minus 9 gives us 11 over 4. We come down, we write for every x belonging to the set of real numbers, which is the domain, we know x plus 3 over 2, all this squared will always be greater than or equal to 0. Next step, we are going to add 11 over 4 at the left hand side and at the right hand side of this inequality, plus 11 over 4 is greater than or equal to 0 plus 11 over 4 remains 11 over 4. We know this is our function f of x, so we write for every x belonging to the set of real numbers, f of x is greater than or equal to 11/4. Now you can write down the range. Our range will simply be y equal to f of x such that f of x is greater than or equal to 11/4 for x belonging to the set of real numbers. This will be the range. We go to question C. For question C, we have to find the range of f of x equal to 5x minus 1 minus 2x squared. X is equal to 5x minus 1 minus 2x squared. We know we can write this down as negative 2x squared plus 5x minus 1. Next, we are going to factor negative 2. So we make the equation of x squared to be unity. Factor negative 2 times x squared. We know negative becomes positive times 5/2x plus negative positive gives us negative plus we have close the bracket. We know negative 2 times here gives us negative 1. Now we can apply the gymnastic of completing the squares here. So this will give us negative 2 times x squared minus 5/2x plus a half the coefficient of x. A half of negative 5/2 is simply negative 5/4. We add negative 5/4 all this squared plus a half. Then we subtract negative 5/4 all this squared plus our brackets. So this will simply be equal to negative 2 times, we know this is a perfect square, which the factorization is simply x minus 5/2 all this squared plus a half minus negative 5 squared gives us 25 over 4 squared gives us 16. Close the bracket. This will be equal to negative 2 times x minus 5/2 all this squared plus, you know, the LCM of 2 and 16 is simply 16. 16 divided by 2 gives us 8. 8 times 1 remains 8 minus 16 divided by 16 gives us 1. 1 times 25. 25. This will simply be equal to negative 2 times x minus 5/2 all this squared plus, we take 8 minus 25, it gives us a negative 17 on 16. Close the bracket. This will simply be the same as we expand. This will give us negative 2 times x minus 5/2 all this squared plus, we know negative gives us positive plus, we know 2 will go into 16 here, 8 times plus 17 over 8. Now we write for every x belonging to the set of real numbers. We know that x minus 5/2 all this squared will be greater than or equal to 0. Next, if we multiply both sides by negative 2, the inequality sign will change, will reverse to less than or equal to, negative 2 times 0 remains 0. Next, we are going to add the 17/8 to both sides plus 17/8. It will be less than or equal to 17/8. We know this is a function f of x. It simply means for all x take from the set of real numbers, f of x is less than or equal to 17/8. Now we can write down the range. The range will simply be equal to y equal to f of x such that f of x is less than or equal to 17 over 8 for x belonging to the set of real numbers. So this is the range of values of the function f of x equal to 5x minus 1 minus 2x squared. We go now to question 2, which says if ax squared minus 8x plus 2 is equal to 0 as repeated roots, find the value of a. Question 2, ax squared minus 8x plus 2 is equal to 0. It has repeated roots. We have to find the value of a. We know for the quadratic equation to have repeated roots, then the discriminant b squared minus 4ac will be equal to 0. If we compare this quadratic equation, ax squared minus 8x plus 2 equal to 0 with the general form of a quadratic equation, ax squared plus bx plus c equal to 0, we have a to be equal to a, b to be equal to negative 8, and c to be equal to 2. So if we make use of the formula for discriminant, the discriminant is simply equal to negative 8 over the squared minus 4 times e, which is a, times c, which is 2. So this will give us negative 8 squared gives us 64 minus 4 times a gives us 4a, 4a times 2 gives us 8a. The discriminant is equal to 0 for repeated roots, then 64 minus 8a will be equal to 0. We get to make 8a the social formula, then negative 8a will be equal to negative 64. Then, for us to get a, we are going to divide both sides by negative 8. And this will give us a to be equal to 8. Let's write down the conclusion. Therefore, a will be equal to 8 for ax squared minus 8x plus 2 equal to 0. So have repeated roots. We go now to question 3. Question 3 says find the range or ranges of values of k for which question A we have kx squared plus 4x plus 3 plus k equal to 0 to have real roots. A kx squared plus 4x plus 3 plus k equal to 0 to have real roots. We know firstly for a quadratic equation to have real roots, that means the discriminant, which is given by b squared minus 4ac, must be greater than or equal to 0. We're going to start by comparing kx squared plus 4x plus 3 plus k equal to 0 with ax squared plus bx plus c equal to 0. If we compare, we have a to be a, b to be 4, and c to be 3 plus k. We know our discriminant will be equal to, replace b with 4 squared minus 4 times a is k, times c, which is 3 plus k. This will give us 16 minus, take 4k, negative 4k times 3 gives us negative 12k. Negative 4k times k gives us negative 4k squared, which is the same as negative 4k squared minus 12k plus 16. At this level, we can factor out negative 4. We factor out negative 4. This will give us k squared plus 3k minus 4. Negative 4 times negative 4 gives us 16. Negative 4 times 3k will give us negative 12k. Now the discriminant will be greater than or equal to 0 for this our quadratic equation to have real roots. Then negative 4 is k squared plus 3k minus 4 will be greater than or equal to 0. If we divide both sides by negative 4, the inequality sign will reverse. So this will give us k squared plus 3k minus 4 to be less than or equal to 0. 0 divided by negative 4 remains 0. If we divide this side by negative 4 will cancel this negative 4. So this will give us k squared plus 3k minus 4. And k squared plus 3k minus 4 can be factorized. Let's factorize factorizing k squared plus 3k minus 4. We need two numbers such that the sum is 3 and the product is equal to negative 4. 4 negative 1. 4 negative 1. 4 plus negative 1 is 3. 4 times negative 1 is negative 4. This will simply mean 4k squared plus 3k minus 4 will be the same as k squared plus, I'll replace 3 with 4 minus 1. No positive negative here, negative will stay, times k minus 4. This will give us k squared plus, I'll expand 4k. Negative 1 times k gives us negative k minus 4. I'll take the first pair, k is common, I'll factor k times k plus 4. The second pair will factor negative 1 times k plus 4. We have two terms in which k plus 4 is common. Factor k plus 4 times k minus 1. So this is the factorization of k squared plus 3k minus 4. And we insert it in this our inequality here on the left hand side. Therefore means we have k plus 4 times k minus 1 is less than or equal to 0, which is a quadratic inequality. So the first thing we need to start by finding the critical values. Write down these critical values. And for us to get the critical values, we are going to equate k plus 4 product of factors times k minus 1 to 0. Then this will mean that either k plus 4 is equal to 0 or k minus 1 is equal to 0. Then k will be equal to negative 4 or k will be equal to 1. So these are the critical values. If you look at the two critical values, you will notice that the negative 4 is less than 1. If we let y to be equal to k squared plus 3k minus 4, in this case you will see that the equation of k squared is 1. That means our a is equal to 1. Because this is a quadratic function in terms of k. And a is equal to 1, which is greater than 0. That means the curve of y equal to kx squared plus 3k minus 4 is a valley parabola with roots negative 4, 1. Let's make use of the first method. if we draw this, this is our key axis. The critical values we have for -4, -4 is less than 1, so to the left we have -4. We put our ring. If the inequality it is less than or equal to 0, so the rings will be shaded. Because the critical values are also part of the solution. We shade the rings. The next critical value we have k as 1. At 1, so we shade the ring. Such. We have a valley parabola that goes through these critical values. As such. So this is it. Then we have y. If this is our y is less than or equal to 0. Less than or equal to 0, that means we are going to shade this lower portion of our curve. This is it. And for us to give the required range of values or ranges of values of k, we are going to copy the values of k for the shaded portion. We have -4. Since the ring is also shaded, the ring is shaded, we make use of less than or equal to k. It's less than or equal to 1. Because at 1, so the ring is shaded. Then we conclude therefore -4 less than or equal to k less than or equal to 1 is the required range of values. Okay. If you make use of the sign table, you will still obtain the same result. Question B says we have kx squared plus 3x plus k minus 4 is equal to 0 to have two real distinct roots. B, we have k x squared plus 3x plus k minus 4 equal to 0 to have two real distinct roots. In order for a quadratic equation to have two real distinct roots, then the discriminant must be greater than 0. The discriminant, which is b squared minus 4ac, must be greater than 0, strictly greater than. If you compare kx squared plus 3x plus k minus 4 equal to 0 with ax squared plus bx plus c equal to 0, which is the general form of quadratic equation, our e will simply be k, our b will be equal to 3, and our c will be equal to k minus 4. So if we insert them, this is our formula for the discriminant. Our discriminant will simply be 3 squared minus 4 times k times k minus 4. This will give us 9. 3 squared is 9. -4 times k gives us -4k times k gives us -4k squared. -4k times -4 gives us positive 16k. We can write this down as -4k squared plus 16k plus 9. At this level, we can factor out let's factor out -1. This will give us 4k squared minus 16k minus 9. -1 times -9 gives positive 9. Next, we are going to see if we can factorize 4k squared minus 16k minus 9. Let's write this down. Factorizing 4k squared minus 16k minus 9. So we need two numbers such that their sum is equal to negative 16. We add them. And their product is equal to 4 times negative 9, which is simply equal to negative 36. For the two numbers, we say if we take 2 plus negative 18 gives us negative 16. 2 times negative 18 gives us negative 36. This will give us 4k squared minus 16k minus 9 to equal to 4k squared plus, I'll replace negative 16 with 2 plus negative 18. We know positive negative will stay. 2 minus 18 times k minus 9. Push this to be equal to 4k squared plus 2 times k gives us 2k. Negative 18 times k gives us negative 18k minus 9. If we take the first pair, see that 2k is common, we factor 2k times 2k gives us 4k squared plus 2k times 1 is 2k. The second pair we can factor negative 9. Negative 9 times 2k gives us negative 18k. Negative 9 times 1 gives us negative 9. We have two terms in which 2k plus 1 is common. 2k plus 1 times 2k minus 9. So this is the factorization of 4k squared minus 16k minus 9. We are going to insert it here, therefore means our discriminant will be equal to negative, put the negative sign in front, negative 1 times 2k plus 1 times 2k minus 9. Now for this our quadratic equation to have real roots, the discriminant must be greater than 0. The discriminant is greater than 0, therefore means negative 1 times 2k plus 1 times 2k minus 9 will be greater than 0. Next, we are going to multiply both sides here by negative 1, which we multiply both sides by negative 1, the inequality sign reverses 2k plus 1 times 2k minus 9 to be less than, it changes now to less than 0 times negative 1 remains 0. So this is our quadratic inequality. In this case, let's make use of the sign table. First thing, we need to start by finding the critical values. The critical values are very important when solving inequalities. For the critical values, we are going to equate the 2k plus 1 times 2k minus 9 to 0. If we equate them, we are going to say either 2k plus 1 is equal to 0 or 2k minus 9 is equal to 0. Here this will give us 2k to be equal to negative 1. Here 2k will be equal to 9. Negative 9 crosses, it becomes positive. Next, we are going to divide both sides by 2. We divide here by 2. 2. Then we divide by 2. Here by 2. So this will give us our k to be equal to negative a half, or our k to be equal to 9 over 2, which is simply the same as 4 a half. Now we can make use of our sign table. If we compare the critical values, you will see that negative a half is less than 9 over 2. We make use of our sign table. We have key, the first column. Next, we have get the test values for key less than negative half, key less than negative half. Next, we test values between negative half and 9/2. We have negative half less than key less than 9/2. Next, we test values for key greater than 9/2. It's still the same thing. You can make use of the sign table. You make use of the graphical method to get the required range of values. For the first row, we have 2k plus 1. For the second, we have 2k minus 9. Lastly, we have 2k plus 1 times 2k minus 9. 2k plus 1 times 2k minus 9. Now we are going to test the values for that required range. Then we write down just the signs. We take k less than negative half. Let's take k to be negative 10. 2 times negative 10 gives us negative 20. Negative 20 plus 1 gives us negative 19. The sign is negative. 2 times negative 10 gives negative 20. Negative 20 minus 9 gives negative 29. The sign is negative. Negative negative gives us positive when we take their product. The next, negative half is less than k. K is less than 9/2. This range we can take 0. 2 times 0 is 0 plus 1. 1, the sign is positive. 2 times 0 is 0 minus 9. Negative 9, the sign is negative. Take the product, positive, negative, the sign will be negative. We go to the next. K is greater than 9/2. 9/2 is the same as 4.5. So we can take a value of, let's say, 10. 2 times 10 gives 20 plus 1, 21. The sign is positive. 2 times 10 gives 20 minus 9 gives us 11. The sign is positive. Positive, positive. The product will be positive. Looking at the sign table, we have to get the required range of values for 2k plus 1 times 2k minus 9, such that it is less than 0. At our sign table, less than 0 simply means it is negative. So this will be the required range. You can see it here. It's negative. For the other ranges, it is positive. Here we conclude. Therefore, negative half less than k less than 9/2 is the required range of values. This is the required range of values for the quadratic equation kx squared plus 3x plus k minus 4 equal to 0 to half two real distinct roots. For question C, we have kx squared plus 1 is equal to 4kx minus 3k to have a real root. Kx squared plus 1 is equal to 4kx minus 3k. We can arrange this. We know this will give us kx squared minus 4kx plus 1 plus a negative 3k crosses it becomes positive plus 3k is equal to 0. We're going to write comparing. You can say this is a quadratic equation now. Comparing kx squared minus 4kx plus 1 plus 3k equal to 0 with the general form of the quadratic equation x squared plus bx plus c is equal to 0. We have to be equal to k, b to be equal to negative 4k, and the c to be equal to 1 plus 3k. We know that for the quadratic equation to have real roots, that means the discriminant b squared minus 4ac must be greater than or equal to 0. Our discriminant, we insert the values for b, a, c, negative 4k squared minus 4 times a, which is k, times c, which is 1 plus 3k. So this will give us 16k squared. Negative 4 times k is negative 4k, times 1 gives us negative 4k. Negative 4k times positive 3k gives us negative 12k squared. We can arrange this. We take 16k squared minus 12k squared gives us 4k squared minus 4k. See that 4k is common. We can factor out 4k. 4k times k will give us 4k squared. 4k times negative 1 will give us negative 4k. We know that for real roots, our discriminant must be greater than or equal to 0. Then 4k times k minus 1 should be greater than or equal to 0. At this stage, if we divide both sides by 4, 4 is a constant, this will give us k times k minus 1 to be greater than or equal to, since we are dividing all through by positive number, the inequality sign will remain unchanged. 0 divided by 4 remains 0. Next, we need to find our critical values. Critical values are very important. For us to get the critical values, we are going to equate k times k minus 1 to be equal to 0. And then k will be equal to 0 or k minus 1 will be equal to 0. So this will give us k to be equal to 0 or k to be equal to 1. So these are the critical values. In this case, we are going to make use of our sign table. So for the first column, we have k. The second, we test values for k less than 0. Since 0 is the smallest critical value. The next, we test values between 0 and 1. And lastly, we test values for k greater than 1. For the first row, we take k. The second row, we take k minus 1. And lastly, take the product k times k minus 1. For k less than 0, if we take negative 2, the sign of k will be negative. Negative 2 minus 1 is negative 3, the sign is negative. Negative times negative gives us positive. 0 and 1, between 0 and 1, we enter the less than sign here. If we take a half lies between 0 and 1, value of k will be positive. A half minus 1 gives us negative a half, the sign is negative here. Positive times negative, the resulting sign is negative. K greater than 1, if we take, for example, 3, the sign is positive. 3 minus 1 gives 2, the sign is positive. Positive times positive gives us positive. So looking at the sign table, The required range of values of k for k times k minus 1 to be greater than or equal to 0 will simply be, here we have positive for the product, positive for the product. So the required ranges of values will simply be k less than or equal to 0. Because when k is equal to 0, it's also true. Or k greater than or equal to 1. When k is equal to 1, you have 0 too, which is also true. When it is equal to 0, the roots will be repeated. We conclude, therefore, k less than or equal to 0 or k greater than or equal to 1 are the required ranges of values for k. For that quadratic equation to have real roots, we can also write this as, can give it as a set k such that k is less than or equal to 0 union k is greater than or equal to 1. So this is how we find the range of a quadratic function by making use of the method of completing the squares, and how to find the required range of values for an unknown for a quadratic equation to have real roots, two real distinct roots, or for it to have repeated roots. So if in case you have any worries, you can ask your questions at the comment section. Please, if you like the video, please share and do well to subscribe to this YouTube channel. Thank you very much for watching.